We've got our Spring app working, and it's still running here on the left window. I've opened the second window. You can open lots of these windows on the WSL because they're fairly lightweight. And we're going to work on the Angular, the front end part. So we're going to our projects directory, and what do we need to do? Well, the first thing is let's explain what Angular is. It's a TypeScript or JavaScript-based framework which is used for building single-page web applications, and it was developed by Google. So Angular runs under Node. So the first thing we need to do is install Node, and you can, within Ubuntu, you can do that sudo apt install npm. That installs a Node package manager, and from there you can install Angular, and you just need the Angular command line interface, so Angular CLI. That you would do with npm, using the npm command, install -g at Angular CLI 11.2.14, and that should download and install, and that lets you create template applications, and also has an inbuilt server for running Angular applications. So it's Angular command line interface, and you see I'm on 11.2.14 and version 14.7.3 of Node. So again, I think Node latest version is 18, so I'm a few versions behind, but that doesn't change anything from the demo because it's the same command. Let's create a new application, and let's call it, I don't know, as our Spring Boot is serving a message, hello Spring Boot, we'll call it traditional hello world. This is an old favourite from the C, and if we run that command, it asks us a few questions. It says, do you want to install strict type checking? Yeah, why not? I like strict type checking. Do you want to add Angular routing? Yes, but we're not going to use it in this project. So as we see, that's now installed everything, and if we look under a project directory, we've now got another directory called Hello World. We'll change into that, and there are different IDEs for developing on Angular. I've installed VS Code, Visual Studio Code, because I wasn't able to run the Angular IDE for some reason. I think it's probably due to some way in which this computer is set up. I wasn't able to run it from the Ubuntu environment. So Visual Studio Code, you can just download that as a Debian package if you're using Ubuntu, WSL Ubuntu, and then just install it as given the instructions on the Visual Studio Code page. And if I type, so let's see, yeah, there's some stuff in there. If I type in code dot, okay, that's is advising me to install Visual Studio Code on Windows subsystem. The problem is I don't have control of the firewall on my PC, and my Visual Studio Code on Windows won't create a socket over to Ubuntu. It's blocked, so I have to run it. And why not? I've got an X front end. Why not run it on Ubuntu? And there we go. Visual Studio Code comes up. Now we're in the Hello World project, and let's have a quick look around at what we've got in here, the basic. So this code's all been generated for us, so that saves us creating all the boilerplate, which is really nice. And if we go into the source directory, we see there's a file called index.html. So as I said, Angular application is a single page application, and if we look in the code, we find index.html, and if we look in that, there isn't a great deal. But this is a file that we would initially load in our browser, and it loads all the required TypeScript files from the Angular framework, as well as our own applications code and templates. And the only thing you see in here that maybe hints at that is this little tag app root. And what happens If we go back over here and type ng-serve, it will compile our application and it injects code into this index.html file to actually do something useful. So see, we've actually done no coding as of yet, and if we go over here and open a new tab, you'll see this is the index. So this is the index.html. There's just a title of Hello World. If you go here, you see the title Hello World, but all of this has been added, injected into our index.html. Hello World app is running, etc. That's great. But that's not the app we want. That's just to show that everything's up and running nicely. Normally, we don't have to touch the server again because it will detect any changes we make and it will reload the application. As you do that and reload the application in the browser, or recompile the application and reload it in the browser. What else have we got here? I've got a main.ts. So main.ts identifies which Angular modules should be loaded when the application starts. In this case, we're loading core basically, and that's it. The kind of entry point is this class or this object here, app module, which is in this file here. And that module is the starting point for the application specific code. This is the core configuration of the application. It loads dependencies, it declares components, and marks the entry point into the application. So you see here, it's loading our routing that we configured when we created the skeleton app. It's also loading app component, and you can see here we're bootstrapping app component. App component, this is the actual application itself. Obviously you can have lots of components, services and other things, and it's, if you like, this is the model, if you like, because it has the data for our application, and it the view onto that model is all of this HTML here. So this is a visualization of what's in that component, and it's what was displayed. It's all this HTML that's displayed here. So the title, this message here, and all of this stuff. And what we're going to do is replace all of this with a call to our Spring Boot application. So we're going to do that now. And we're going to use a client called HTTP client, which allows us to make REST calls. So the first thing we'll do is go into appmodule.ts, and we actually want to load the HTTP client. So we'll change that code. No, don't have that. So what we've done in app module is we're now loading the HTTP client module. So we import it and we declare it here in the module startup. That's good. Now, what we also want to do is, if we go back here, this is our application. We will actually stop serving that for a second. And we want to create a service. So we want to structure this code reasonably well. We're going to create a new module, if you like, here, which is going to be a service, and that service is going to be what makes a call out to our Spring Boot backend. And we can do that rather than having to write code. We can use the Angular command line interface, and we can type ng-generate service it's going to be, and we'll call it, so it could be a component, in this case a service, and we'll call it message. And you see it's added two files, message service spec, we don't need to touch that, and message service, which is a bare bones message. And what we want to do is use this to call our client. So I'll edit this code to add a bit of extra. So what are we doing now? We're calling in, we're referencing an observable class. Well, I'll explain what that is. So we're referencing the HTTP client library here. We are creating a new class called message service. We're hard coding a URL to our backend application. We shouldn't do this at all. This should be configurable and passed in when you create the constructor. Constructor passes in an HTTP client object, called HTTP. And here we have get message. And what this will do is use the HTTP get method, exactly as if you went into a browser and typed in this URL, and it's going to load this URL. Now, this is done asynchronously because a call to another web application may take some time, so you don't want your whole application hung up while you wait for that call to come back, and that's where the observable comes in from the RxJS library. Basically, this returns an observable, and the observable lets you subscribe on the get call, and when the data is ready, the Angular framework will call your application with the data. And that might be 10 milliseconds later, it might be 5 seconds later. Eventually it will time out. I'm not quite sure what the timeout is. And what we're going to do is make some modifications to the code that was generated, in this case app components.ts, and we are going to call our message class. Well, we're going to declare it, and then we're going to call it. So here's our new code, and the important thing, or our update to app component.ts, and the important thing is we're now referencing the message service, which is in our current directory, so /message service, and we are going to set the title to something different, so you can see the changes, and we've added a variable called response, and we are in the constructor, we are passing a message service object, and we're going to use that message service object. So we're going to call the get message method, which, as you remember, returns an observable, and we're going to subscribe to that observable so that when the data is returned, we'll set the response object to that data, and if there's an error, we'll log that error. Great, well that sounds pretty good. We should all be up and running. No, we want to make one last change. Let's go to app component. Let's get rid of, can we do a select all? And we're going to reference the title in this h1. If you put basically to reference the variable, you put it in this double brace syntax. And we're referencing as well a response. We're actually referencing response.message. If you remember what the microservice returns, is a bit of JSON in our case, a name and a value, and we say response.message, it will actually output hello from Spring Boot. At least that's what we hope. So everything should be good to go at this point. Then if I hadn't stopped ngserver to create the service, that would all get automatically reloaded. So we need to restart. We need to rerun ngserve. Should compile everything. Compile successfully, that's good. So it should be serving the application. Have a look at what we've got. You know what I didn't do? I need to save everything. So if I click Save All, look here, it recompiles everything. And if we go here, you see the title. If we go back to our, we want to do that, or that. If we go back to our app component, you'll see title Spring Boot, but we're not seeing the response. Let's open the inspector so we can debug that. We'll have a look at network first. Reload everything. There's the call out to localhost, it's the HR call, so asynchronous request. and it returns 200. That's good. Response headers all look good. So it's making a call to the back end. If we go over here, is it showing any? Yeah, it shows here. I think that's the call that was made. And let's have a good response. Okay, there's no response. Let's see, there's a console. Yeah, there is a console message. And it's saying access to HTML requests has been blocked by the calls policy. Now, okay, calls is cross-origin. It basically stops a front end that wasn't served from the back-end server from making a request to that back-end server. It's a security mechanism to stop people calling your back-end server from maybe some kind of rogue application, that kind of thing. Now, there are different servers, but it's on the same host. I didn't realize that applied. So we can change our back-end server to say that we trust this front end. How do we do that? I'll stop the server. And yeah, I know you can add an annotation called the cross-origin annotation. So we've got our get mapping here. It's got to go there. What we're basically saying is we're trusting anyone contacting our application's referrals set to localhost 4200. So it's the same server but a different port. And Automator to report that class. And we should be good to go now. So I'll run the application again. Yeah, I could have run it through IntelliJ and then I'll be able to debug the application as well. And we go back here and look at our local host. It's good now. And we've got the return message hello from Spring Boot, and here we're displaying just the value of that JSON. So there we go, we've got an Angular application that's calling a Spring Boot backend. Just to remind you about this Spring Boot backend, what we changed was the demo application we renamed to the application. We didn't make much of a change in there. We added a message controller to handle requests to root, and we made a change we created a unit test so that we can check that there aren't any regressions on our code. That will be run every time we launch the application or the build. And we didn't. What's important is we did this all through annotations. We didn't create any long-winded XML files like you used to have to do in the past with Spring. It was all coding. So it's very neat, and it's a Spring framework that replaces the annotations with the actual code and configures everything in its own framework. So it's very neat, very clean code, and as you see, pretty quick to get everything set up and running. So anyone from the Python or community, I've done a lot of Python programming recently, and you can use Swagger files to create services, and it's fairly quick to do, but it's really no quicker than developing in Java these days with modern tools like Spring and Angular. Thank you very much for listening, and if you didn't see part 1, I will go back and have a look at part 1 now.